class, we had a discussion about chain isomerism. In that, we had a discussion about skeleton number. Dear students, what is the skeleton number? A skeleton number is a two-digit number. For example, you can go for a 4-2. It is a 50. It is a 6. So this is called a skeleton number. Skeleton number is a two-digit number. Skeleton number is a two-digit number. Two-digit. You can take any number. So the first number, the first digit is represented total number of carbons in the parent chain. Total number of carbons. Total number of carbon atoms in the parent chain. So parent chain is also called as a skeleton chain also. Parent chain. The second number, this is the second number. This number is represented total number of side chains. It is the number of side chains. Number of side chains. So that in case of chain isomerism, what we discussed, for chain isomers, the skeleton number must be different. Is there? It is called chain isomerism. If the skeleton number is not the same or remains a constant, so this type of isomerism is called positional isomerism. So today we are going to discussing the positional isomerism. So dear students, please take the pen and paper and write on all the points. So second, structural isomerism is called positional isomerism. It is the positional isomerism. Dear students, what is the common statement will come here? Compounds having same molecular formula having same molecular formula, I will write MF, and the same molecular weight, but different, but differ in the position, of atom or group, or even multiple bonds. Dear students, what is the multiple bonds? Either it is a double bond or it is a triple bond. Your group mean you will take any functional group or atom also. So this is called a positional isomerism. So compounds have same molecular formula, same molecular weight, but differ in the position of atom or group or even multiple bonds such as double bond and triple bond. And what is the note here? Like in the chain isomerism, I said skeleton number must be different. Is called chain isomers. Here, the skeleton in both compounds, in the both compounds, the size of parent chain, the size of parent chain, the size of parent chain and side chain must be same, See that, for example, example is given. One butene is there, CH2, double bond CH2, it is a CH. So what is the numbering? 1, 2, 3, 4. What is the IUPAC name, students? It's called 1-butene. 1-butene. And how I am going to write the position isomerism? So what in the definition itself says that there is a the position of multiple bonds are different is called position isomerism. So here I am going to write CH3. It is a CH double bonded CH, it is a CH. So it is called 2-butene. 2-butene. So 1-butene and 2-butene are which type of isomers, students? These are called positional isomers. 1-butene means double bond is located first position. It is 2-butene. In the 2-butene, double bond is located in second position of the carbon. Hence, 1-butene and 2-butene are which type of isomers? Positional isomers. And what is the one more it is? I will write like this. It is a CH3, CH3, doubly bonded, it is a CH2. So numbering is allotted 1, 2, it is 3. What is the UPSC name of this compound? It's called 2-methyl, 2-methyl, 1-propene, 1-propene. See, they may ask you relation between the 1 and 2. So compound 1 and compound 2 are which type of isomers? Positional isomers. Compound 1 and compound 3 is, see, double bond is located first carbon, double bond also located first carbon, but where is the difference? The difference in the parent chain or a skeleton chain. These two are called, it's called chain isomers of each other. Chain isomers of each other. We'll go for example. Example 2. C3H6Cl2. Total how many isomers are possible? We are talking about position isomers. Once you try it, students, total how many isomers are possible with the molecular formula C3H6Cl2? Yes. First one is CH3, CH2. Then I will keep two halogen atoms on the same carbon atom. Same carbon atom. Numbering is allotted 1, 2, it is 3. What is the UPS name? 1, comma. It is 1, comma 1. Dichloropropene. 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 What is the second isomer? I am going to change the location of atom. CH2, Cl, CH2, CH2. Now it is a Cl. Numbering is assigned 1, 2, it is a 3. IUPAC name is given 1, comma 3, dichloropropane. Dichloropropane. See, what I have given in the definition, compounds have same molecular formula, same molecular weight, but differ in the position of atom. See that? Chlorine is one of the atom. So position of the atom, such a isomer is called positional isomers. And one more it is, third compound is, we'll give two chlorine atoms on the same carbon atom. Same carbon atom. It is the CH. Numbering is assigned 1, 2, 3, 1, comma, 2, comma, it is a 2, dichloropropane. Propane. And last one is found. Now I am going to keep the two chlorine atoms on adjacent position. Possibility is there or not? Yes, possibility is there. So numbering is assigned 1, 2, it is a 3. So it is called 1, comma 2, dichloro. How many carbons in the parent chain? That is called propane. So my dear students, here the chlorine atoms are attached on the same carbon. Here chlorine atoms are arranged terminal carbons on the terminal carbons. Now here chlorine atoms are attached on the same carbon atom. Here the chlorine atoms are attached adjacent position of the carbon. So in all cases, we changed the position of chlorine atom. So change in the position of atom or group or even multiple bonds such as double bond and triple bond is called positional isomerism. Positional isomerism. See, what they are going to ask you question in that. The question is how many number of carbon atoms required for alkanes to show position isomerism? How many number of carbon atoms required for alkane to show positional isomerism. So positional isomerism. What is your answer? The answer is how many minimum number of carbons are there? It is called 6 carbon atoms are required. That is called hexane. Next question. What they are going to ask you? Question is how many minimum how many minimum number of carbon atoms required for, now we will see alkene to show positional isomerism. The answer is, guess it, what I am going to write. Number of minimum number of carbons are required for alkene to show position isomerism. That is called 4. So 4 means 2, 3, 4. That is called 1 butene. And next one is 2, 3, 4. It is called 2 butene, students. So minimum how many number of carbons are required to show the position isomerism? So number of carbons are 4. And next, how many minimum number of carbons? How many minimum number of carbon atoms required for alkynes? For alkynes to show PA, position isomerism. The answer is how many number of minimum number of carbons are required? It is also 4. See, 1, 2, 3, 4. Now it is called 1 butane. 1, 2, 3, 4, 5. And out I am going to write the position isomerism. 2, 3, 4, 5. Now I am going to keep the triple bond second position. 1, 2, 3, 4, 5. Hence, minimum number of carbons are required for alkynes to show position isomerism is the 4. Next, how many minimum number of carbon atoms are required for alcohols? For alcohols, that is the question. That is the answer is 3. 3 Cl. For example, it is a CH3, CH2, CH2, 1 OH, 1, 2, 3. See that. What is the functional group is there in the alcohol? This is the OH group is there. Now I am going to change the location of CH OH group. See that. Now OH group is attached on which carbon atom, students? The OH group is attached second position of the carbon. Now it is a 1, it is a 2, 3. It is called 1 propanol. It is called 2 propanol. Or which type of isomers? It is called position isomers of each other. So minimum number of carbons are required for alkanes. What is your answer? It is a 6. How many minimum number of carbons are required to show the number of carbons are required for alkene to show position isomerism? Is what is your answer? The answer is 4. The minimum, how many minimum number of carbons are required for alkynes to show position isomerism? So answer is 4. Minimum number. How many how many minimum number of carbons are required for alcohols? So your answer is 3. So is it clear, students? Then suppose in the rings, how we are going to find the answer? In the rings, for example, it is now it is called there is a only one chlorine substituted benzene. You can change the location of Cl on the benzene ring so that you may get the same answer. Here there is no Pa here, no Pa, no Pa. There is no position isomerism. Now it is called 1-chlorobenzene. If I am going to write the Cl here, that is also 1-chlorobenzene. Now I am going to insert, I am going to substitute 2 chlorine atoms on the benzene ring. Can you tell me position isomerism is possible? Yes, obviously there is a position isomerism is possible. Now see that it is called 1,2 dichlorobenzene. Then you change the location of chlorine on the benzene ring. Now it is the 1 Cl here. Now it is called 1 Cl here. What is the location 1? It is the 2. It is the 3. So that it is called 1,3 dichlorobenzene. Next. Now here 1 chlorine and fourth position 1 more chlorine. So this isomer is called 1,4. So dear students, in the ring substituted hydrocarbons, we got 1,2, 1,3, 1,4, 1,4. Then if there is a 3 chlorines are substituted on the benzene ring, Cl. So what is the isomer it is? So location is 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. Trichlorobenzene. This is the first isomer. Second isomer will be written like this. Looks like a symmetrical. Now it is called 1 Cl. Now it is a 1 Cl. It is a 1 Cl. So what is the location here? 1, 3, 5. Trichlorobenzene. One more possibility. I am going to write like this. So here 1 chlorine, here 1 chlorine, here 1 chlorine. So numbering is selected 1, 2, 4. Trichlorobenzene. Trichlorobenzene. So that this is called 1, 2, 1, 2, 3 trichlorobenzene. 1, 3, 5 trichlorobenzene. 1, 2, 4 trichlorobenzene. So in that way we are going to write the positional isomers in the different compounds. Next, we have a next isomer is called ring chain isomer. It's called ring chain isomer. Ring chain isomerism. Ring chain isomerism is merged into function isomerism. Ring chain isomerism is merged into functional isomerism. See how I am going to define. Same molecular formula. It means that compounds have same molecular formula, but a different mode of linkage. It means that open chain and a closed chain. of carbon atoms. Carbon atoms. See, in a simple way, we are going to define like this. For example, the molecular formula C3H6 has the following types of isomers. See that. First, I am going to write the open chain isomer. Second, I am going to write the closed chain compound. C3H6. 3 to the 6. It means that it is one of the alkene. Dear students, in case of alkenes, two more extra hydrogen atom will be there. In case of alkenes, exact number of hydrogen atom will be there. It means 3 to 3 to the 6, 4 to the 8, 5 to the 10, 10 to the 20. So, exact number of hydrogen atom will be there. The same molecular formula will be written like this. So that this the given molecular formula is alkene. Now I am going to write CH2 double bonded CH. It is a CH. Now this compound is called open chain. It is right. This is the open chain. Now you see here how I am going to write the closed or it is a ring chain. Total how many carbons we required? 3 carbons. So this will be written like this. So this is the answer. Or this meaning is cyclopropane. It is called cyclopropane. Do you understand, students? One compound is a open chain compound. One more is a closed or a ring chain. This kind of isomers, see that how they are going to ask you question. One propene is a ring chain isomer with cyclopropane. One propene is a ring chain isomer with cyclopropane. Again, I will repeat. One propene is a ring chain isomer with cycloalkane. We will go for one more example here. I will take butene. What is the butene formula? In alkenes, exact number of hydrogen atom will be there. 4 to the 8 I will write. 4 to the 8. Yes. Now tell me here. One is called, you write down alkene open chain, that is called CH2. W bonded, it is a CH. CH2. Now it is a CH2. The compound is given, it is a open chain. It is. One is called open chain, we have written a nest. What is the closed? Total how many carbons are there? 4 carbons are there. This will be written as a closed ring. It is closed. See that? This is the closed. Or else, what is the meaning of this compound is simply we can write cyclobutane. It is called cyclobutane. Cyclobutane are unsaturated. This is called, sorry, cyclobutane is a saturated. This is called unsaturated double bond is there. So that it is called a ring chain, ring compound. It is called ring compound. See that. Again I am going to write like this. Total how many carbons in the parent chain? 4 are there. Now I am going to degree the size of parent chain. Now it is become a 1 methyl cyclopropane. 1 methyl cyclopropane. Now see that this compound and this compound are which type of isomers? They are obviously chain isomers because of total number of carbons in the parent chain are 4. Here total number of carbons in the parent chain is 3. The size of the parent chain must be different is there. Here what is the skeleton number, students? In this case, cyclobutane is there. It is called 40. Here it is skeleton number is 3, 1. So that skeleton number must be different is there. It's called a chain isomers of each other. Chain isomers of each other. Next one is We'll go for one more example, that is called fifth one is C6H12 is C6H12. C6H12. Tell me guys, given compound is alkane, alkene. So simple way, 6 twos are 12 is the exact number of hydrogen. So I will go for first of all, it is an alkene open chain, 2, 3, 4, 5, it is a 6. You can write down either here, double one here, second position or here. Now it is one of the open chain. It is the open chain compound. Next, open chain compounds are the ring chain isomers with the closed chains. Now, total how many carbons we required in the ring? There is a 6 carbons are required. Now it is called, what is the skeleton number? The skeleton number, total number of carbons are required to construct the ring 6. It is the first one. Now, decrease the size of the parent chain. Now we'll keep 5 carbons in the parent chain. Still one more carbon is required. Now what is the skeleton number here? It is a 60. Here what is the skeleton number? It is a 5. 1 is the. And the third one is, now again I am going to decrease the size of the parent chain. Now shall we write down still how many carbons we required? 6 carbons are required. So that I'll write like this. So skeleton number 1, 2, 3, 4. So it is a 4, 1. Skeleton number is a 4, 1. And a third compound will be written. Now these the how many carbons on the side chain? There is a 2 are there. Now I am going to divide it into 2 small groups like this. 2 methyls on the same carbon. So that what is the skeleton number? It is called a 4, 2. And the fourth one you will write like this. Now I am going to change the location of methyl groups. Now here it is here 1, it is 2, it is 3, it is 4. What is skeleton number? Number of carbons in the parent chain 4. Number of side chains are 2 only. And next one is the fifth one is, now again I am going to decrease the size of the parent chain. Now I am going to write like this. I am going to write like this. Now here one ethyl group, here it is called methyl. So that it is a, see that in the carbon in the side chain total carbons are 2, here also 1 is there. So skeleton number is it is called 3, 2 it is. Again one more I am going to write like this. 1, 2, it is a 3. So 3 comma total number of carbons in the parent chain is a 3 it is. Next, one more possible isomer is, I am going to write like this. 1, 2, 3, 4, 5, 6 are there. What is the skeleton number? It is the skeleton number is 3, 1. One more it is I am going to write like this. It is also possible. So 1, 2, 3, 4, 5, 6 are possible. So these are the possible isomers in the cyclic compound. So what the question is, open chain compounds are ring chain isomers with all these compounds. See that one hexene is a ring chain isomers with all these compounds. Now, so the question is, cyclohexene is and 1-methyl cyclopentane are not cyclic isomers. These two are the chain isomers. Why? Because the skeleton number must be different is there. The skeleton number must be different is called. It is called chain isomers, I said. 6 and 5 1 it is. Both are skeleton number is different. Now see that it is called 4 1 is there. So 5 1 and 4 1 both are skeleton number is different. Hence it is called chain isomers. Now it is called 4 2 also skeleton number is different. Is then it is called chain isomers. Now in this way, these are the, see that all these compounds. See the question is one hexene are ring chain isomers with all these compounds. But cyclohexane, so cyclohexane, these are the compounds are position as well as the chain isomers of each other. So cyclohexane with the cyclohexane, all these compounds are chain as well as a positional isomers. Is it clear, students? Next, very important topic. It is very important for competitive exams also, my dear students. Please take the paper and pen and write down all the points. It is the functional isomers. How we are going to write the functional isomerism. Functional isomerism. Functional isomerism. As usual, we'll write the definition. It is the compounds having same molecular formula. Compounds having same molecular formula. I will write MF, students. MF means molecular formula. But a differ. But a differ. Where the difference will come in the functional group. The functional group. Functional group are called functional isomerism. And the phenomenon is known as a functional isomerism. The phenomenon is known as functional isomerism. These examples are important. Sometimes they may ask you questions in the NEET level as well as a JEE level also. Yeah. Alcohols and ethers are functional isomers. So that alcohols and ethers are which type of isomers? Suppose you have in doubt, here we can. What is the functional group in alcohols? OH. What is the functional group in ethers? It is called O. See that? Functional compounds having same molecular formula, but there is a different functional group is there. Such a kind of isomers are called functional isomers. See that? Your functional group is OH is there. In ethers, what is the functional group is there? It is called O is there. So, compounds having same molecular formula but differ in the functional groups are called what I said? It is called functional isomers. The phenomenon is known as a functional isomerism. Now, what is the general formula of alcohols and ethers? The general formula it is Cn, it is H2n plus 2 and it is a O. These are the general formula of alcohols and ethers. See that. For example is it is a C2S6 O is there. C2S6 O is there. Here one oxygen they have given this oxygen. In alcohol also there is a one oxygen will be there. Ethers also one oxygen will be there. So we don't know whether it is ether or it is alcohol. Now see. First we write down alcohol with the two carbon atom. It is CH3, CH2. Now it is called OH group is there. And next one is ethers with the two carbon atoms. It is the CH3. Now it is the O. Now it is the CH3. See that? Compounds having same molecular formula. But where is the difference? The difference is in the attachment of functional group here. So this is the functional group. Here one OH group will come. Here it is a one O is there. So compound having same molecular formula that is C2H6O also O. So alcohols and ethers are which type of isomers? Functional isomers of each other. And next one is second example is aldehydes is called CnH2n. It is the O. This is the general formula. See that with the general formula CnH2nO, CnH2nO, it can be aldehyde, it can be aldehydes, or it can be ketone, it can be ketone, or unsaturated alcohols, unsaturated alcohols, or unsaturated ethers, or it can be cyclic ether also. It can be cyclic ethers. Here lengthy compounds I have written with the molecular formula CnH2nO. CnH2nO. See what are the functional group will come here. One is called aldehyde. It is a ketone, or it is unsaturated alcohol also. Unsaturated means that is a double bond will come. Here it is unsaturated ethers also will come. And it can be a cyclic ether also. So my dear students, with the molecular formula CnH2nO, it may be aldehydes, it can be ketone, it can be unsaturated alcohols or unsaturated ethers, or it can be cyclic ethers also. Now we will go for detailed information. First compound will be written like this with the molecular formula C3H6O. So first what I have given aldehyde, it is a CH3, it is a CH2, CH2, W bonded O with the 3 carbon, same molecular formula is there. So it is one of the aldehyde functional group is there. Next one is one more, it is a ketone with the 3 carbon atom CH3, W bonded O. It is called ketone is there. Now it is the ketone functional group. Next, it it can be unsaturated alcohol. It means that there is a double bond also will come in the compound. CH2 W bonded. It is a CH2. Now it is called OH will come. Yes or no? It is called unsaturated. One double bond is there. Unsaturated alcohol. Next, it can be unsaturated ethers also. Unsaturated ethers also. It is the ether I have written like this with the same molecular formula. Next one is it is called cyclic alcohols also. Cyclic alcohols. So we want three carbons in the ring form, one OH group. Now it is a cyclic ether also. See that now I have written like this one. It is called oxytone. What is the compound name? Oxytone it is. Oxytone. Oxytone. And I'm going to decrease the size of the parent chain here. Now I'm going to keep this ring is looks like a 3-membered ring. Now here I'm going to write a CH. Now what is the name of this compound is called 2-methane. It is called 2-methane oxyrane. 2-methane oxyrane it is. 2-methane oxyrane. So numbering is given 1, with a 2, with a 3. Now here the IUPAC name is given. It is called methoxy. Methoxy. It means that it is the 1, it is a 2. Methoxy. Ethene it is. Methoxy ethene. Yes, methoxy ethene. So the molecular formula C3 H6O has the following isomers. So first one is called aldehyde, students. This is the aldehyde CH2. Now this group is called a ketone, and it is called unsaturated. One double bond is there, one OH group is there. Unsaturated alcohols. It is unsaturated ether. Now this is called cyclic alcohol. It is a cyclic ether. The name is given oxytone. And this is again, see, total number of carbons in the parent chain, 4 are there. Now I'm going to decrease the size of the parent chain. Now I got this is the 2-methyl oxyrene. Very, very important. This is very important. Make it a star mark also. Next one is, we'll move on to next category. The molecular formula, that is CN H2N O2. O2 is there. You can guess it. Two oxygen atom. In which functional group? Two oxygen atom will come. One is called acid. One is called acid. In acid compounds, two oxygen atom will come. Ester also. In esters also, two oxygen atom will come. And next one is called hydroxycarbonyl. It is hydroxy. It is a carbonyl. Hydroxycarbonyl. It is possible two oxygen atom in the following compound. Now we'll take one formula. It is called C3H6O2 is there. So the molecular formula C3H6O2 has how many type of functional isomers? So the first one is CH3, CH2. Now it is C double bonded O. It is called OH group is there. Now tell me, student, what is the functional group is there here? The functional group is acid is there. Acid. The functional group is acid. Next, one more compound is given. It is the ester. What is the ester formula? It is a CH3, C double bonded O. It is a O, CH3. So, general formula will be written like this. It is called R, C, W bonded O. It is called O, R dash. It is called ester general formula. So instead of R, methyl is there, CW bonded O, it is a O, and instead of R dash, this R and this R both may be same or different also. This is called ester. So what is the ester functional group here? So this is the ester functional group is there. And next one is hydroxy carbonyl is there. Hydroxy carbonyl. That is all right, CH2. It is the one OH. Hydroxy mean OH group will be there and carbonyl group also will be there. Carbonyl mean aldehydes and ketones are collectively known as carbonyl compounds. Now see that it is CHW bonded O is there. Now tell me guys, now this part aldehyde functional group is there. Hydroxy carbonyl compounds we got. Next I am going to write the ketone here. That is CH2. Now it is called OH. Now it is C double bonded O. Now it is a CH3. See, it is hydroxy group is there. Now this is functional group is called carbonyl group is there, and here also one OH group is there. See that hydroxy aldehydes, hydroxy ketone. So aldehydes and ketone are collectively known as carbonyl compounds. Aldehydes and ketones are collectively known as carbonyl compound. So that, my dear students, with CnH2nO2, this formula has acid, ester, hydroxy, carbonyl isomers we have. Next one is, and fourth we will go for, it is the cyanide. It is cyanides and isocyanates. It is called isocyanates. Cyanates and isocyanates are functional isomers of each other. Cyanates and isocyanates are functional isomers of each other. So what is the general formula? R C triply bonded N. So in the cyanide group, between the carbon and nitrogen, one triple bond will come. And what is the isocyanide here? It is called R N triple bonded C will come. See that the carbon is directly attached to the hydrocarbon chain, but in the isocyanide, the nitrogen atom is directly attached to the hydrocarbon chain. So carbon is attached to the hydrocarbon chain is called cyanide. When nitrogen is attached to the hydrocarbon chain is called isocyanide. Isocyanates. You see the difference. For example, it is the CH3, CH2, CH2, and it is C triply bonded N I have written, and CH2, CH3, CH2, CH2, N triple bonded C is there. My dear students, the Cn is attached, cyanide is attached to the hydrocarbon chain, is called cyanide. When Nc is attached, when the nitrogen is attached directly to the hydrocarbon chain is called isocyanide. Now what is the name of this compound? IUPAC name is given. It is the 1, it is the 2, 3, it is the 4. Now tell me what is the answer. Now it is called butane nitrile it is. It is called butane nitrile it is. Now this is called 1, 2, it is a 3. So that it is called propyl. So N is attached to the direct to the hydrocarbon atom, hydrocarbon chain. It is called propyl, isopropyl, isonitrile, isonitrile. Next, we'll move on to fifth one, alcohols and phenols. Alcohols and phenols are functional isomers of each other. Alcohols and phenols are functional isomers of each other. See that? Now here I am going to attach the CH2, it is called OH. Now here it is, see that difference you notice. Now it is called OH group is attached. Now it is called CH2 group is attached. The OH group is attached to the, not to the directly aromatic ring. It is attached to the aliphatic carbon. It is called alcohol. Now you see that this OH group is directly attached to the aromatic ring. Now it is called phenol it is. This compound is called phenol, and this compound is called alcohol. It is called normal alcohol. Now this is called benzyl alcohol, and it is called cresols generally. So on the benzene ring, one OH group and a CH2 group is there. It is called cresols. It is one OH and a CH2 is there. It is called cresols. And next one is, we'll move on to next example. 1 degree, comma 2 degree and 3 degree amines are 1 degree, 2 degree, 3 degree amines. 3 degree amines. Amines are functional isomers of each other. Are functional isomers of each other. Of each other. 1 degree, 2 degree, 3 degree amines are functional isomers. See that? How to identify the 1 degree amine? See that? In 1 degree amine, the symbol will come NH2. Next, 2 degree amine is there. So, this is the 2 degree amine. And 3 degree amine mean like this symbols will. So 1 degree NH2, 2 degree NH, 3 degree only N will come. 1 degree, 2 degree, 3 degree amines are functional isomers of each other. We will move on to one example. It is a CH3, CH2, CH2, NH2 is there. Tell me student which kind of amine it is. NH2 group is there, what I said, it is called 1 degree amine. Next, 2 degree amine will be written CH3, CH2, NH, it is the CH3. So that what is the nature? Now this is called 2 degree amine, it is called 2 degree amine. And next 3 degree amine, CH3, N, CH3, now it is the CH3. So that this is called a 3 degree amine. So my dear students, in 1 degree amine, the nitrogen, the functional group NH2 is attached only one alkyl group. In 2 degree amine, the NH group is attached, so two alkyl groups. Now, around the nitrogen, here how many alkyl groups are there? 3 alkyl groups are there. Now this is called 1 degree amine is called 2 degree amine, it is called a 3 degree amine, it is called 3 degree amine. So 1 degree, 2 degree, 3 degree amines are functional isomers of each other. And student may get a doubt here, see that 1 degree, comma, 2 degree and 3 degree alcohols, alcohols and alkyl halides, alkyl halides are not functional isomers, functional isomers, but they are chain and positional isomers, students. Chain and positional isomers. Please remember this point. So 1 degree, 2 degree, 3 degree amines are functional isomers of each other. But 1 degree, 2 degree, 3 degree alcohols or it is alkyl halides are not functional isomers, but they are chain and positional isomers. Chain and positional isomers. We'll move on to next example, that is called amide case. Amide. What is the amide? So this is the functional group CW bonded. Now this is called NH2 will come. This is called amide. It's called amide. Amide. In case of degree is defined, it is a if degree is different. Degree is different. So these are also called as a functional isomers. So degree is different. This is called functional isomers. See here? Example will be written like this. CH3, CH2, CH2, CW bonded O. It is NH2. Now this group is amide, right? Is called amide. Next, second will be written like this. CH3, CH2, CW bonded O. This will be written NHCH3, NHCH3. Now this is called 2 degree amide. 2 degree amide it is. 2 degree amide. What is the third one we can write? CH3, W bonded O, NCH3. It is also CH3. Now around the nitrogen, how many alkyl groups are there? So the nitrogen is attached. How many other carbons? 3 carbons. Hence it is called 3 degree it is. 3 degree amide it is. 3 degree amide. So it is called 1 degree amine is the NH2. Now this group is called 2 degree amide. Now this is called 3 degree amide. So here also 1 degree, 2 degree, 3 degree amides are functional isomers of each other. Functional isomers of each other. Next, one more also it is there, that is called amide. Amides and oximes are functional isomers or functional isomers. Functional isomers. Amides and oxime. You know, oxime we studied in the carbonyl compounds. That is called nucleophilic addition reaction followed by elimination of water. You may get an oxime. So first one is it is CH3, CH2, W bonded O. It is called NH2. Now which group is the here students? Amide group is the. Next I am going to write the oxime. CH3, CH2, CH, W bonded N. Here I am going to write one OH. Here one lone pair. See, molecular formula is same. What is the molecular formula? 3 carbon atoms are there. How many hydrogen atoms? It is the H7 is there. And one O is there. And here also 1, 2, 3, 3 carbons. Hydrogen 3, 5, 6, 7 is there. How many oxygen atoms are there? 1 is there. See that. Compound having same molecular formula, but a different functional groups. Now see that it is called oxime. It is called W bonded NOH is called oxime. Now here CW bonded NH2 is the answer.